Alright, hi guys and welcome. Today we'll be talking about organizing data using matrices and actually doing a little bit of operations with them. Okay, so some stuff to talk about with matrices. Matrices are actually a really integral part of computer science and a lot of mathematics, especially some of the linear algebra and geometry fields of study. Okay, and matrices are just rectangular boxes that just order the information, okay? Right, so they kind of look like this with the brackets. All right, and just so you know, rows go across, so rows go like this, and the columns will go up and down. So C, O, L, U, M, N. Okay, so rows go across, columns go up and down. Pretty simple just to work with it like that. Okay, I like to actually write it like this. Kind of looks like a cross. There we go. Haha. Pretty simple, pretty neat. Okay, now organizing the data, you would just go from left to right, top to bottom. Okay, so it's pretty simple as reading that. Alright, so that's what a matrix is. It's just a way to organize information. Now, if I wanted to know, let's say I was dealing with a matrix that looked like this. There we go. Alright, and I wanted to find out which specific number was in a certain place. Let me move this up a little bit. Okay, I would actually look up the address. So the address of this 4, and let's call this matrix A. And you always call matrix by a capital letter. Okay, so 4 would actually be A, and then you would have underneath it a 1, comma 1, because that would be the first row, and then you would have the column. Okay, and that's how you order it right there. Now, if I wanted to know what was in A 2, comma 1, okay, I would look at the second row and the first column, and that overlap would be this 8 right here. So that would actually be the number 8. Okay, so that's how we actually look up that information and just work with it. Now that we have all these kinds of orders, can we do some operations with them? Yes, you can. You can add / subtract the matrices you want as long as they're, oh, I got too many R's in that, as they're the same size. Okay, so as long as they're the same size, they have the same number of rows and same number of columns, you're okay. Okay, adding and subtracting. Now, scalars are a little bit different. So let's say you actually had a scalar with it. Let's say scalar with this, 6a. Alright, so what that would mean is that I'm going to actually have a 6 in front of the bracket. Right? Let me see, we got 4, 7, 8, 9. Okay, all right, and so when it's like this, what you would have to do is you would have to distribute the 6 to everything in there. And so 6a would actually turn up to look a little bit like this. All right, and we got 24, 42, 48, and 54. And that's what it would look like. So that's what scalar multiplication looked like. Now, can you mix and match some scalar multiplication with addition and subtraction? Yes, you can. So, like for example, let's say you wanted to have 5a minus 4b plus negative 2c. Okay, so what you would do is you would take 5 and times it by everything in matrix A, and then you would take 4 and times it by everything in matrix B, and then you would subtract the 2, and then you would times everything in matrix C by 2, and then add that with the result of this. Now, the one thing you do need to understand is that there is some multiplication, but you will talk about that in Algebra 2. But for right now in Algebra 1, we will just be working or worrying about the plain old plus, minus, and scalar multiplication type of work that we are working with, okay? All right? All right, and that is pretty much it for working with this. Oh, sorry, one last thing. You can actually have two matrices equal to each other, and then you can set up equations to actually solve for equivalent parts. Okay, so let's say we have something like this. So let's say we had 4, -1, 3, 7, okay, and then we had a 2x, 5y, 3, and 14z. Okay, something set up like this. Or you know what, let's make that a 14 minus z. There we go. That looks much better. Okay, now this looks like a bunch of gibberish at first, and you're like, what does this mean? Well, what this equal sign is saying is that these two matrices are equal, and if you look in the second row, first column number, they are both equal, so that means that these two are equivalent. Okay, and what that means is I can find the value of the variables by setting these equal to each other. Okay? All right, so if I set it up down at the bottom, 4 equals 2x, -1 equals 5y, and 7 equals 14 minus z. Oops. And I could actually solve all of those and actually get the answers. So I could get x equals 1/2, y equals -1/5, and z equals, let me see, 7. There we go. And you could actually find it just by setting those two equal to each other. And this one, at first, is the most confusing for a lot of students, but once they see, oh, just equivalent addresses are the same, then you're all good to go. Okay? All right. That's it for dealing with organizing data using matrices. I'll talk to you later. Bye.